Okay, welcome everyone to lesson 10.5. Now, for a lot of you, this is going to be kind of a review lesson when we first started the unit on circles, but we're following along with Geometry Nation, so this is going to be kind of a reminder for a lot of you. Some of you, this might be a new lesson, so I'm going to show you how each problem is going to be worked. And so you'll see that we'll have 6 different problems that you'll have to complete um, for your assignment grade, along with your Geometry Nation. And so every number that you see next to the problem is going to correspond with the problem number on the assignment that will be given to you. So here we go. So in this lesson, we're talking about tangents. Tangents that form the outside of the circle. Now, when you have two tangents, so you remember a tangent is a line that touches only in one location on the edge of a circle. If it meets somewhere outside the circle, they will always be congruent. So, excuse me, in other words, if this is 8, this of course would be 8. Now, let's look at an algebra problem. So number 1, you're going to have a problem that you're going to have to solve for x. Well, we have two tangents that are meeting on the outside of the circle, so that means these two tangents are congruent, and we can set them equal. So 6x minus 4 equals 2x plus 12. Let's solve for x. 4x minus 4 is equal to 12. Add 4 to both sides. 4x is equal to 16. And when you divide, x equals to 4. And it's that simple. Now, problem number 2. This is where it gets really tricky. In this problem, we've got to figure out what x is by setting these two equal to each other. But look what's going to happen when I do. You get x squared equals to x plus 12. This is a quadratic. Now, since this is a quadratic, there's two ways you can go about it. One way would be the quadratic formula, but don't worry, we're not going to do that yet. And the second way is to factor. Okay, you learned in Algebra 1 how to factor quadratic equations. So what I'm going to do is show you a couple examples of how to factor, and then we'll show you how this is solved. So let's look at a couple examples of factoring. Let's say that we have x squared plus 4x minus 12, and we want to factor this. What we're doing is reverse FOIL. Reverse outside, first, outside, inside, last. So I place my x's here and here. Now, I don't know how your Algebra 1 teachers taught you this, but there is a simple method that you first look at the last number. All right, this is negative 12. And what I want to do is say, what times what gives me 12? Well, I have 1 and 12. I could have 2 and 6. I can have 3 and 4. These are the factors or the numbers you can multiply to get the number 12. Now, look at all these numbers here and decide when I add or subtract which ones could give you 4. Well, if I add 1 and 12, I'll get 13. 12 minus 1, that gives you 11. That does not give you 4, so we know 1 and 12 can't be it. 2 and 6. 6 plus 2 is 8. 6 minus 2 is 4. So it's probably 2 and 6. Now let's check 3 and 4 to make sure. 3 plus 4 is 7. 4 minus 3 is 1. That does not give us 4. So 2 and 6 would be your two numbers on the ends. Now we got to decide plus and minus. This is a positive 4, that's a negative 12. So in other words, when I multiply these two numbers, I got to get a negative. So that means one's a positive, one's a negative. Well, how do you know which one is which? Well, look at this number. It's a positive 4. So that means the larger number needs to be positive. Now, if this was a negative, then it would be different. So this is a positive 6 minus 2. Now, when you FOIL this, you get x squared, 6x. 6x minus 2x is 4x. And negative 2 times 6 is negative 12. When you get to this part right here, you're going to set it equal to 0. And you solve for x on both of them. But here, let me give you just a quick shortcut. All you're going to do is write down the opposite of each number. So the opposite of negative 2 is positive 2, and the opposite of positive 6 is negative 6. So x is equal to 2 or negative 6. If I plug this into our picture, then either one would give you a correct answer. Alright, now let's go back to this problem. Now notice how it looks a little different. I have x plus 12 over here on the right side. Well, I need to get it over here on the left side. I need to get it with the x squared. So I subtract x. So x squared minus x is equal to 12. And then subtract 12. So x squared minus x minus 12 equals to 0. Now let's factor. I have x and x. Now let's think, what number times what number gives us 12? Well, we already did that. So we have 1 and 12, 2 and 6, 3 and 4. But this time I need a negative 1. Now where I get negative 1 from? Because there's no number in front of the variable x. So it's like an invisible 1 there. So looking at these three, which one could I get a negative 1 by adding or subtracting? This was 13 and 11, 4 and 8, 7 and 1. So 3 and 4 would be it. Now let's look at this. We've got to decide which one's positive, which one's negative, because we need a negative 12. Well, since I have a negative 1, that means the larger number needs to be negative. So I'll put a negative here and a positive here. This gives us negative 4, positive 3, which is negative 1. 3 times negative 4 is negative 12. Then I told you, write down the opposite. So x equals negative 3, or x is equal to 4. If I plug these in, you'd get a correct answer. Alright, so if I put negative 3 here, negative 3 squared would be 9. And if I put negative 3 here, negative 3 plus 12 is also 9. 9 equals to 9. Now let's try with 4. I put 4 here, 4 squared is 16. Put 4 here, 4 plus 12 is 16. 16 equals 16. And this is how you'll do number 2. Now at any point that you feel like you need to pause the video so you can see what I did, then you can pause it, go back through and work it exactly the same way step by step. Alright, now let's look at number 3 and 4. Now this should be familiar to some of you. We actually did a problem like this if you're talking about Mouché's classes. We did this earlier on. Anybody that has not gotten to this part, it's really not that bad. You have to use the Pythagorean theorem in order to solve it. So what they're going to ask for is either what is the variable or what is the radius. The radius. So in other words, we want to find out what is the length of the center to the edge of the circle, the radius. So I'm just going to put a little r there, variable r. And we're going to use the Pythagorean theorem because when we talk about tangents in a circle, they always form a 90-degree angle, always 90 degrees. And when you have a tangent and you form a triangle, it will be a right triangle. Therefore, we can use the Pythagorean theorem. So let's call this A, B, and C, of course, will be the longest side of the right triangle. Write down the Pythagorean theorem. A squared plus C squared, B squared equals C squared. And let's see how we solve. Well, in the place of A, we have R. So that's R squared. B, 36 squared. C, this is not 24R. I have several students year after year that want to say R in 24 is 24R. No, this is R plus 24. So R plus 24 squared. Now let's simplify. R squared, use your calculators. 36 squared is 1,296. Now here comes the biggie. R plus 24 squared. This means this. R plus 24 times R plus 24. So we're going to FOIL this out. So R times R, R squared, 24R, and 24R gives you 48R. So you got to make sure you add the 24 and 24. And then we have 24 times 24, and that gives us 576. Now let's solve for R. Thank goodness our R squares cancel out, so you will not have to factor or do the quadratic formula. Let's bring the 576 over. Minus 576. This gives us 720 equals to 48R. Divide, and the radius is 15. And that's how you find the radius or the variable of number 3 and 4. So I'm going to give you another one. Pause the video, try it, and see what you get. Find the radius of this circle. Alright, so let's see what we get on this one. You should have marked this as A, B, and the hypotenuse C. So A squared plus B squared equals C squared. This is R squared plus 24 squared equals to R plus 12 squared. R squared plus 576 is equal to, well, let's see what R plus 12 squared is going to give us. So R and R squared. 12R is 24R. And 12 times 12, 144. R squares cancel out. Subtract 144 from both sides. 432 equals to 24R. Then divide, and R equals to 18. So good job if you got 18 as your answer for this one. Alright, let's move along to number 5. Number 5 is actually a really simple problem because it actually gives us the radius of being 12, but we need to find x. X is from the outside edge of a circle to the end of where this tangent is meeting. So we need to find this length. Now the easiest way to do this problem is just simply the Pythagorean theorem and subtract. Alright, let me show you what I'm talking about. Let's say this is A, B, and C. Let's ignore the x. Let's say it's not there and just do the Pythagorean theorem. So a squared plus b squared equals c squared. So this is 12 squared plus 16 squared equals c squared. 144 plus 256 equals c squared. 144 plus 256 is 400. That's equal to c squared. Take the square root and you get 20. Now what is 20? 20 is this hypotenuse. Of course I don't want that. I want x. Now how are we going to get x if this whole thing is 20? I need another number. Well, the radius remains the same no matter where you go on the circle. So if this line is 12, this would also be 12 because the radius remains the same. Now I can solve it. This is 20, that's 12, here's x. So 20 minus 12 gives you 8. So x equals to the 8. There you go. Now we got one more problem. It's actually, I think, probably the easiest out of the 6 that you're going to do. And it looks something like this. You're going to have to solve for the perimeter. Now when you do the perimeter of this problem, you're just simply matching numbers with each tangent. So all these are tangents because it's touching in one location. So in other words, this tangent is congruent to that one. This tangent is congruent to this one. And this tangent is congruent to this one. So let's just go ahead and transfer the numbers. That's 10, so this is 10. 20 and 20, 15 and 15. Then we're just going to add all the numbers up. So 20 plus 20, 10, 10, 15, and 15. And you get a total of 90 as your perimeter. Alright, and this serves as our lesson today. And if you have any questions, please message your teachers, and we'll try to help you best that we can. Alright, y'all have a good day.